Hi everyone, welcome to day 18 of Spark Learning. So, today we are going to talk about the continuation of performance optimization. So, today we'll cover optimize, vacuum, and partitioning. So, partitioning we have already covered in the earlier sessions. However, we will touch base and I'll show you how partition looks like in the delta tables. Okay, so we'll move on to the data bricks. Yeah, so we are today we are going to talk about optimization performance. In that, like the table maintenance session, optimize, vacuum, and partitioning, what we are going to cover. So let us start with partitioning. So partition is nothing but creating a separate grouping or folders while storing your data, so that help you to retrieve the data faster, right? So I'm going to create this table which is having name, department, and salary. So I have different department: HR, IT, finance, these three departments. So what I'm doing here is like I'm creating a test table under day 18 folder. So let me run this. So my expectation is like I wanted to store the entire data as delta files, but it has to be partitioned in the form of department. So I'll go to catalog. We'll go to day 18. So I have this test table which I created now. So you can see the log file, like when we have a delta tables created, we'll have log files and the data files. So you can see department equal to finance, department equal to HR, department equal to IT. So this is how partitioning look like. If you have like 5 departments, it will be creating 5 folders and the data will be stored inside it. It may be one file or multiple files. So how does this help? The partition will help you to arrange the data according to the partition key. It's like here in this case department. So when you are going to filter the data, like department is finance, the system need to come directly into the department finance data, and it can pull all the files from here. It need not to scan the data from HR or IT. So that is how partition would help you to improve the performance of your read operations. Okay, now since we are here, finance have one file, HR have two files, department is also having another two files, right? Because this is based on the data. You can see for every tuple it has created one file. But if you look at it practically, do we really need one file for one tuple? No, right? It is going to read three tuples. So that there is where optimize comes into picture. So before I do that, let me also do an additional operation, as I'm appending another two record. Like for HR and IT, I'm going to append two records, two tuples. So let me run this. So how this data gets stored, right? So is it going to add data into the file which is already there, or is it going to create a new file? So that is what we are going to see directly in front of our eyes. We have like added these two records in the same test table. I'll go to the catalog, go to DBFS, test table. So previously when we were checking at HR had two files. Now it become three. When you go to IT had two files, it become three, right? So now what you have understood is like for every tuple, it is adding a file. So that means like if you are have 100, you are keep adding every insert, it is adding an additional file into your folder, right? So here is where optimize comes into picture. We learned that okay, this now we have around like 5 plus 2 7 files. This is not an optimized method. We don't need this many files to be managed, and we don't want to like read all these files, right? We wanted to like optimize and reduce the number of files which has to be stored in an optimized way. So what I'm doing here is like I'm running this describe command. Describe command will give you some basic information. Then I'm running my, so I'll run this. So we can use that spark sql.show, but that does not give you a readable format, where I am interested only in the number of files here. So you can see it resulted as 7. That means like we have 7 number of files, correct? So then I'm running this optimize. Uh, so I'm running this selected. So it ran. Now I'm going to run. I'm going to run my describe again. So let us see if there is any changes in it, right? So you can see the number of files are changed to 3, correct? So it was 7 earlier. We did an optimize, it become 3 because 3 is all you need, right? Because you don't have so much of data, you have very limited data. So let us see how it look like in the data folder, right? Go here, test table, finance. So finance was like were never be a trouble. Okay, so it was showing 3, but it has still all the 7 files in the folder, right? Okay, so here also you have your all 4 files here in this. Okay, so 4 plus 4 plus 1. So here this is the same one file 4, then here you have 0. Yeah, so you have actually after your optimize, you have additional files. When you count the files in this folder, you can see additional files, but it is saying you have only number of files are 3. So what happened actually in the behind the scene, system has optimized your data, and it created 3 files and generated that. So now you have other all 3 files that is marked as like removed or deleted state, so that like when you start writing the query, only that one file would be used, whereas like other files will not be used. However, they will continue to be there in your locations. Here the only the latest file would be used, but however other files will be there, so they no longer like they will continue to be there. So how we would remove that? Do we need to remove that? Yes. So you understood that. Now your delta table is only referring this table, and your read is going to be faster than when it was reading 7 files. Okay, so when you understood that you had like 4 files in your HR department folder, whereas like you are only using 1, you don't need those 3, right? So that is a garbage, or that is an unnecessary data when you look at your current state of your data. So that is where vacuum coming into picture. Vacuum will help you to clean up your old file. But keep this in mind. It is like when this we used optimize, but when you do this update delete operations, every time like the files are coming in, right? It keep adding files into your respective folders. So this vacuum would help you to clean up this file which is no longer in use, correct? Which is like delta creates a new file and mark the old one as removed. Sorry, old one as removed in the transaction log. However, those old files are not deleted immediately. They remained in the storage for time travel and rollback purpose. Read this statement clearly. They remain in the storage for time travel and rollback purpose. So that means like they did not keep that file for just like they cannot delete it, right? So they have keep it for time travel. So you say, okay, I did an optimize. I wanted to go back to previous state. I did a delete statement. I want to go back to the previous state. So in that case, system is going to refer your this removed or deleted or like we can call it as removed files, which is marked as removed, would be using as a reference to go back to your previous state. So these files are needed, right? But at the same time, when you look at today's status, they are not needed. It is kind of a versioning. Every change when you make, there will be a new removed file created, and like the current file would be removed, and you will have a new file created. So when you like delete that remove file, your like time travel going back to that particular state will be gone. So now we can use vacuum to clean up this old file. So vacuum can impact your time travel. You know that, right? So vacuum will clean it. So when we can use vacuum, you need that you have a need of this is consuming your storage, which may or may not be required, right? So you think that I don't want to roll back to previous state, I don't want to see the history and all. So you can clean them up right away, you don't need to worry. So how it works, vacuum by default keep 7 days of retention. So that means how you would code this, by default you run is like vacuum delta table. So anything more than 7 days would be anything more than 7 days old would be cleaned up, and rest will be remainder. Okay, you can also force retain to a couple of hours or whatever, but that is not recommended because you are losing that backtracking or rollback feature. So keep that in mind while using vacuum. So here what I am doing, I am forcefully disabling that the retention duration check by using this keyword like delta retention duration check enabled. I'm making it as false. So otherwise, if it is true, if I try to use this retention command, this is going to throw an error, I'll not be able to do it. But given I wanted to demo you like how this change would affect, I'm forcefully making this as false. Now I have this, yeah, this was my test table. Our test table is different because before I do this demo, I need to test, right? So this is our test table. So we have seen in the test table you had additional files, correct? Yeah, here you are not going to see any changes, however, but I'll run this. I'm running all these commands, so this is going to be false, and your test table retention is 0 hour, because that means anything which is are removed are going to be gone. Okay, then I'm trying to get this result, but not this in mind. There is no change on the number of files which you are going to notice, because this is about the present or the latest status of your table is what it is referred, right? So that case your this number is expected to be all same, but the real change is going to happen in where it is stored, right? So my expectation is like your test table HR department folder is cleaned up. You only see the part 00 file and all other 3 files are gone. When you go to IT department, part 1 is there, all other are gone. Finance, there were no change, it was part 4 earlier, it is still part 4. So that way you lost all this historical table which was not needed, so you cleaned up. So hope this is clear. So vacuum will help you to clean up the files which is not in use. So what are those files? Those files are generated when you do this delete insert kind of operations or you are optimizing. You will have this unused files generated that track. But when you apply, like when you use vacuum, you will use that you will lose that history of the data, so that like you will have limitation in time traveling for a period when you use vacuum. So this is all today we have talked about optimize. Hope this is clear. This example was very clear, and you also have seen how these new files are generated, how this is being combined. And vacuum you have seen with the same example, and partitioning also we mentioned in the same example that partition by will help you to partition the data, and it creates a folder. That foldering is based on the data which exists in your data set, right? So hope this is clear on the optimization side. So this with this, like we are concluding this performance optimization on the delta table. Okay, so that's all for today. Thank you for watching. Have a good rest of the day. We'll see you on the next video.